This is the third part of emotional behaviors. I'm going to continue just the very kind of coming together of what I have been saying about some of those basic theories of emotion, and then start talking about regions of the brain that are involved, but really just the sort of general look at those brain regions, and then talk about the few basic emotions that a lot of scientists discuss. Okay, and I do put back up this summary slide partly to have you all think through, so how do I think this happens, and to think through some examples of your own experiences of emotion, and maybe taking different emotions than just fear, but I'm still going to use the fear example here quite a bit. But I want to make a couple of points. So one, that all of that sensory information, which is really going to lead to a potential emotion in this example, not all the time, but a lot of the times. So in this example of seeing this dog's teeth, hearing this dog bark, all of that information is going through the thalamus. Okay, if I'm in pain, that information is going to go through the thalamus, and then it's going to, for those subcortical brain regions that are leading to the fight or flight response, like the hypothalamus, or leading to this kind of fear response, like the amygdala, that those subcortical regions are much more tightly linked with the thalamus and much more closely linked with the thalamus than this ability to get to the higher level cognitive processing, which we're going to say is happening in the frontal lobes of the cerebral cortex. That information, so if I'm seeing the dog, that information has to go through the thalamus to the primary visual cortex and then travel back up through to be put together with the sound and navigation, where things are and all of that, and then gets to the frontal lobe. So that's going to necessarily be a slower route. Okay, and I usually use this example because for my thinking through all of this. So one example of that I use a lot is, so if I see something that looks kind of wound up in my garage when I'm out there cleaning in my garage, and I think that looks like a snake, that I'm going to have this fear response. And if I had a snake phobia, I might have that fear response and just panic and run, right? But I really don't have a snake phobia, and I'm actually pretty concerned with making sure that the snakes that I see are not poisonous snakes, and I'm not very good at identifying them, so I kind of have to, where I'm at, just get a second look. So for me, I'm going to get that second look because I do have animals and I want them to be safe. So I'm going to get that second look, and it's going to tell me, no, that wasn't a snake, that was a garden hose, right? And you can feel, so when I think I've seen a snake, that autonomic nervous system response of just this momentary panic, but then the second look comes in and you really consciously think about it and go, oh, phew, and that relaxation, a very quick kind of whew response for, that's a garden hose, that's not a snake. So in that case, I feel like that's a roller coaster of emotions that has actually happened to me before. But we do think things through, and where that cognitive appraisal comes might depend a great deal on the situation that we're in. So Callatt here discusses how useful are those theories of emotion, and it leads him to this: is emotion itself actually a useful concept? Because sometimes we have pieces and parts of those three things: the physiological response, some kind of cognitive appraisal, and then some kind of subjective feeling or conscious feeling of an emotion. And we can have two of those without one of them. We can have one and two without three, three and two without one, and so forth, such that it gets difficult to know exactly how useful this is as a concept as we are defining it. And related to that is the question, are we referring to the same thing when we use the word emotion because of those questions? And are we referring to the same thing when we are discussing particular emotions? So when I'm saying I was angry about something, am I having the same experience as when my friend says that she was angry about something? I don't know how much we talked in this class about something like, are we experiencing the same redness or the same experience of the color red when we are looking at the color red, but that is that we might not be, and we don't know. And so these words from about emotions are even more kind of complex and unclear as to whether I'm saying I'm nervous and upset, or my friend is saying she's nervous and excited. Are we feeling the same thing? Is there really some distinction there? And there's also this kind of, with our right frontal lobes, we're doing that kind of labeling of emotions and learning our emotion words, and how good a job really we do of that can influence our experiences of emotions, but then how do we communicate that with other people? And I feel a little bit like I'm babbling, but that these are important, that these are important distinctions to make. So one thing I remember, a friend of mine, every time I would say I was worried about something, she would say, well, I'm concerned. I wouldn't say I'm worried, but I'm concerned. And she had kind of trained herself to use the word concerned instead of the word worried. And it makes a difference in your response, whether or not you feel worried or whether or not you feel concerned. And this also gets us to the more contemporary theories of emotion. One point many of them make is that these responses can range from being very ambiguous of whether I'm afraid versus angry, and how quickly those things can change. As I mentioned, the almost hitting that pedestrian, I was really frightened at that moment, but that quickly turned to anger as I was started yelling at her in this kind of angry. And so that physiological response can mean these more just ambiguous kinds of interpretations and emotions. They can range from being very ambiguous to being very specific and very clear. And I'm also going to talk about a contemporary theory that discusses somatic markers for emotional experience. So this is Antonio Damasio's idea that we have these affective tags, so these tags of affect. Okay, so somatic markers that occur very early in our decision-making processes that help us to make decisions. And so I'll get to that again. I'll come back to that a bit later. So I start talking about the brain areas that are associated with emotion by putting up this picture of the limbic system, which is really where CALIT, I think, starts. Which the limbic system, limbic means border, and it's really this border system between the some subcortical structures and some really middle kind of cortical structures that are included. They are 4 brain structures that are surrounding the thalamus. If you remember early in the semester when we just were doing the brain regions, that sort of neuroanatomy, and I told you you did not need to know what structures were included in the limbic system, because really people disagree. And Joseph Ledoux, who now I've introduced twice earlier in the semester and then again at the beginning of Emotion with that quote, he is one of the people really lobbying to quit calling this a system because they don't really agree about what structures belong here. And it's not just emotion systems, it's emotionally associated memory systems, and sometimes just more explicit, just memory systems are included. So I'm going to start by just quickly discussing here the amygdala and the hippocampus. So the hippocampus being that explicit consolidation of explicit memory. We are going to talk about it and the amygdala a great deal more when we're talking about learning and memory. The amygdala is involved in our processing of emotion, so emotional expression that is on people's faces. Most people have this in their head that it's all about fear and aggression, and it is important for processing fear and for sort of our aggressive responses. And I'm going to talk about that quite a bit more towards the end of discussing emotion. And so it also involves in classical conditioning. So if something that I'm doing is leading to pain, I want to lay that down in memory to stop doing what I'm doing and avoid any response that is leading to pain, and that kind of conditioning. It's the limbic system usually includes the fornix, which is really connecting the hippocampus with many of those other structures that are part of the limbic system. People include the hypothalamus and the mammillary bodies. So we know that the hypothalamus is involved with that fight or flight response and starting the autonomic nervous system. And then the other regions I'm going to talk about are, I'm pretty sure, the cingulate gyrus. So we've already talked about the anterior cingulate when we talked about that emotional part of pain. So the cingulate gyrus, as well as the insula, which we also talked about, I think, briefly when we talked about the emotional or affective aspects of pain, but that is usually also included in the limbic system. It's not labeled here on this picture, but we usually include that. The thalamus can be included. The other areas that are included are the septal nuclei and the olfactory bulb. So actually the mammillary bodies, which are hanging off the hypothalamus, the olfactory bulb, and the septal nuclei, I'm not going to talk about those in this emotion chapter at all. And then there's also the prefrontal cortex. So as we get into the frontal lobes, that's not included as part of the limbic system, as it is this more part of the outer part of the cerebral cortex that is just not included as part of this border kind of system. But the prefrontal cortex is going to have some connections back with a lot of these limbic system structures, and it's really allowing for inhibitory information to come back and inhibit some of these responses. So you might think back to my example of the thinking it's a snake, but it turns out to be a garden hose. So we're going to have that kind of limbic system response, but then the thought through, oh, that's just a garden hose, kind of we can go in with our conscious thinking, planning, determining, decision making, and inhibit some of that just emotional response. This is one of my favorite pictures when talking about emotion because it expresses so much in a picture. And I do this sometimes with attention when I talk about attention of this kind of, this is your brain on attention. And it includes all of these different areas of the brain. And there is a lot that is included in that couched term of attention, right? This kind of really lower level attention, this higher level attention, the am I inhibiting an unwanted response? Am I selectively attending? All of that. Well, emotion is even more kind of complicated with how much is included and how much is involved with our emotional processing. So it gives us these brain images that are showing, so all of the yellow dots, for example, are showing results from different studies of where they found brain activity when they were inducing happiness in somebody. And the blue is sadness, green is disgust, and so on. And you can see again for all of these different emotions, they are really all over the brain. And in fact, it has more to do with the task or procedure of what the participant is doing than it has to do with the specific emotion that they are feeling or that is being induced. So we have localization in the brain seems to exist for the emotion of disgust. And I'm sorry, he says in the textbook that we have a particular place in the brain where we can localize, this is where happiness is. And I don't know what happened there. I don't know if because it used to say disgust, and I don't know how that got changed from an old edition to this edition, but every textbook I have taught from agrees. They agree that we can look for the experience of disgust in the insular cortex. And the insular cortex, so my next little piece there is, it is strongly activated during exposure to stimuli that are perceived as disgusting. And different parts react to different types of disgusting scenes, but disgust is basically localized in the insula. Whether I'm responding to a visual scene that is disgusting, if I'm responding to something that is more conceptual and abstract that disgusts me, so some kind of injustice, or whether I am smelling something that's disgusting, we're seeing this occur in the insular cortex. The insula is also part of the primary taste cortex. We sometimes talk about the frontal operculum, but the insula is also the part of the primary taste cortex. And so it's important, right? If we are smelling something disgusting or tasting something disgusting, that we are having this very fast experience of getting that out of our mouths, and especially if it's something that could be poisonous or dangerous. We also see a reaction to frightening stimuli and angry faces. So it's not that it's completely dedicated to disgust, but that is the, going back up to the first point, the localization in the brain, we seem to see that for the emotion of disgust. So the next kind of question that's asked in the book is whether or not people have a few basic emotions, or what are often referred to as primary emotions, that we consider as being something we see much younger in infants, and that we see across cultures. Whether or not there are 6, 8, 9, it depends. This is kind of a controversial topic, actually. And the person who first came up with this idea that we have 6 basic emotions was Paul Ekman. This was back in the, I think, late 60s, early 70s. And I have this picture from your textbook here. You can look and see if you can recognize these 6 basic emotions, moving from the top left to right, just like you're reading, and then move down left to right. And if you're not sure about any of those, you can go look them up on page 360. You might notice that the bottom, very left, and the very right on the bottom are probably the most ambiguous with each other. But I'm going to let you go look up those answers. One of the reasons we believe that we have these basic emotions, and that where we get this quote from Ekman and Friesen in 1971 of facial expressions appear to be innate, species-typical repertoires of movements of facial muscles. That really comes from Darwin and this idea that he noticed in his infant son, that of emotions that appeared to be innate. Okay, Paul Ekman did this work of going to New Guinea, where at that time they had absolutely no contact with any Western nations. They had no television, no contact, has never seen people from Western nations. And they showed the people from New Guinea those 6 basic facial expressions of people from the United States. And then they showed the people from the United States pictures of the New Guinea people. And this is just one example of a New Guinea tribesman. So if you see in A, they're saying your friend has come and you are happy. In B, they're saying your child has died, and to like make the facial expression that you would make. In C, you're angry and about to fight. And in D, you see a dead pig that has been lying there a long time. Okay, and people were really quite good in both directions of recognizing people from a culture, from a group that we had never had any experience with, of recognizing these emotions. And this was even the ones that were most ambiguous with each other were surprise and fear. I think both of those were not quite 60% correct. But you'll notice that some of this could have had something to do with language, because they don't know how to tell him to just look disgusted in D, they have to say, you see a dead pig that has been lying there a long time. And so that's going to give you this look of disgust. But this appears to be cross-cultural, and that we can recognize each other's facial expressions for those basic emotions. I'm just repeating that basic assumption here from Ekman and Friesen that comes from Darwin, and then showing this picture of, so the person on the top has just won her wrestling match, and she is a sighted person, and you can see not just the facial expressions, but the body language, which I'm also going to talk about a bit here. And the person on the bottom in B there, he is congenitally blind, and he has just won his wrestling match. And you can see that the body expression and facial expressions are very similar. So we do see this similar kind of thing in people who are congenitally blind. It does not look like we have to learn facial expressions. And Callatt makes the point that we rarely interpret emotion based solely on facial expressions. So, as I said, two or more expressions can be present in a single facial expression. Our emotions are rarely this unambiguous, I'm happy and I'm only showing happiness, or I'm angry and I'm only showing anger. They're usually much more mixed than that. We use a great deal of body motion and body language to tell us about a person's emotions. And so he has a great picture in the book. I have taken a different picture from a different book because it was just available to me over to the right there of athletes, where it's really difficult to tell by their facial expression that whether or not they won or lost. We can tell a lot more about their posture, but we can also tell things about based on context. So some people say, of course she won, she's wearing the gold medal. There's the context. We see gestures. So down below at A, B, and C, you can make some guesses about whether or not what those gestures are meaning. I don't completely remember, and I usually get a lot of really different responses that do not match. This is from that Discovering Behavioral Neuroscience by Laura Freeberg, but I think A is supposed to be surprise, and B, I don't know what that is, but it's kind of giving this up in the air, not really a lot of strong emotion. And then C is this kind of, what's going on, maybe a little bit of, I don't know what that is actually. And when I have my classes guess, they're off from what Freeberg said, but the point is we can tell that they are expressing different emotions. We would not put those into the same emotional categories, and that's based on gesture. I usually tell the story here of I have listened to an FBI agent, and this one of those books on tape or books on CD where he's describing how to read body language and tell if people are lying, which is something Paul Ekman ended up getting involved with as well, but not for the FBI, but for different groups. So this is an FBI agent trained in reading body language, and he has this great example of if you have your what's called arms akimbo, so your arms on your hips, or your hands on your fists on your hips and your arms out, that has this kind of, if I talk to you like that, and if you can just go ahead and put your fists on your hips and talk to someone and kind of nod your head up and down, even if you're saying something really benign, it starts to sound a little bit like someone's in trouble, right? And you start to feel like you're talking to someone like they're in trouble. So we have these gestures, and he talks about how this is so we've had animals and dogs as domestic for so many generations. We've trained them to do certain things, but even our dogs can tell the difference between arms akimbo and what you might call, what I would say, C. So when your arms are out open like that. And I can't remember how he described that. And I actually tried that with my dog, who used to never come when I called him. And I wondered if I was using arms akimbo, and I started putting my arms open like that, and he did start coming better when I called. So have someone talk to you like that, a couple, just a few words with each of those gestures, and notice the difference in your own just emotional response to that, regardless of what they're saying. We also have tone of voice, which is so I think it was the last time I taught this class. I was on my way into class. I had already had a couple of kind of bad things happen to me that day, and on my way into work, I almost hit a pedestrian. She walked right in front of my car, and it was a green light. I had a green light, and I was, speeding up because I knew I had to get to through that green light pretty quickly. I know how the lights work, and I knew that I needed to get there. So I was speeding up to go through that green light, and she had those noise canceling headphones on, and she was just bebopping across, and I was already in a state of not being very happy. And I had to screech my brakes and honk, and I rolled down my window, and I yelled at her, and I was cussing, and other people were looking at me. And twice that day when I got in, people asked me, "How are you doing?" And I said, "Fine." And they both said, the one guy said, "Really?" And my teaching assistant said, "You are not fine." And we can tell by a person's tone of voice, even just with the word fine, whether or not that person is really fine, or maybe kind of angry still. I've actually talked about emotion now in a number of ways with the circumplex model, which is one kind of theory of how emotion works, with our emotional theories, our kind of background. But now there's 6 basic emotions, which one of the things I meant to say there too is, so one of the things is of controversy now is, are there 6 basic emotions or 8 or 9? People don't really agree. Scientists don't agree about that. But an alternative view to all of this can really look at emotions as varying along continuous dimensions. So weak to strong, pleasant to unpleasant, approach versus avoid. And while this looks a little bit like the circumplex model with the pleasant to unpleasant, pleasant and weak to strong, this is the idea that there are more these kind of continua of where we are in our emotional states.